Have here is a light fuse, 600 volts AC or less. There's an indicator. If it's good, it's supposed to be white. If you're not seeing white, it's replaced. It's basically a fiberglass reinforcement with epoxy, I assume, held together. It's essentially a US design but assembled in Mexico. What else do we have? Don't know exactly what that means. What that means, haven't looked it up yet. What I'm interested in, since I've seen the mechanism, how it works. This is of course solid copper, and quite substantial. RJ 225, possibly is 225 amps. I am not actually sure, but I will check that out and probably stick that into the video. What I want to do is cut it open, see how this mechanism works, see what they've actually had inside. Never had one of these big fuses before, so let's have a look inside. As could be imagined, lots of fun trying to cut fiberglass facing the wind with the wind blowing the dust at you. Interesting method they use. What it did is a fiberglass core, right, of course with the resin, and what it did is drill some holes in and basically put pegs in. That's what secures this together. So interesting approach. Didn't realize that if I looked on the edge here I would have seen those, but not like I could take those out anyway. Don't have a drill here, don't have any equipment. So yeah, this was probably the only way to do it. So let's throw the sand. As would they expect, sand for quenching the arc would be expected. So let's throw it out and let's see what the actual fuse mechanism looks like. A little less interesting. It seems there's a set of little spikes here. They would have been connected across, and I assume of course once one or two burn, the current would raise, all will burn. Tell is this is a generic base. Again, as I said, copper soldered onto brass. And what they've done is they've put 11 pieces in, but clearly there's space for more, up to 16, so that would affect the rating of this thing. It's really thin, flexible material that's falling apart, so not really sure exactly what material is used to make this. As you see, the sharp edges, so where it's been thinned out, these things look like they're perforated at locations, so they would have just, once they blow, it all burn out. Quenching, I assume. Could be wrong on that, but I assume. And then this, as I said, it's just burnt as the current goes through. It's joined on both sides. As the current goes through, it burns this and it goes from clear to dark. I'll probably just pop this open and see what is in there. Don't expect much though, just something that burns and gets black. As I suggested, it really is just this white piece of material here, and it burns. It gets hot enough, it burns, it becomes black. That's it. This is the side, it's connected to both sides, so obviously the main conductors burn. This is going to take all the load and this is going to burn.